Okay, so science in the primary years program. We should actually put that in brackets next time. So as Joy mentioned, science in PYP is not a standalone subject, which is very different from middle school. In middle school, science, like in traditional schools, will be like a subject, right? But in PYP, it's not. It's part of their homeroom experience, and this is by design. This is part of the IB vision that in the primary years program is transdisciplinary. It means that they inquire into all different subjects, or they pull in all different subjects as part of the unit of inquiry experience. So for example, science in PYP is just one of the lens by which they inquire into a particular unit of inquiry. And this sentence I bolded for a particular reason. I'll read it out to you guys. Science can be used to provide explanations and models of behavior for phenomena and objects around us. This is really important because to me as a science teacher, it is the one point that really brings out the fact that IB has the right vision and matches really well with something called the next generation science standards. Now this is a quote-unquote new science standards in the United States. It's one that has been developed for many years. I think they started rolling it out in about 2014. In public schools, they are supposed to implement this. I've spoken to many public school teachers. I personally don't think they do it well at all. They do not do it well at all in the public schools. And it's because it's really hard to do well. And I'll give you a sense of why I think so. But what I do love about the vision of NGSS is it meshes really well with IB vision of science. And that is that science is all about explaining phenomena. When we were growing up, that's not the case, right? What is science when we were growing up? You memorize facts. You learn it for the sake of learning. You can regurgitate the information. Okay, what's photosynthesis? Okay, it's this equation. What does it really mean? What's its function? What's its purpose, right? Again, nowadays, both in IB and NGSS, that idea of concept is so important. Why do we need to learn science? Because it helps explain the world around us. It doesn't matter if you know all these facts. If you cannot use this fact to explain something around you, then you've not really learned it. And I'll give you guys some examples. So NGSS focuses on helping students to use science to make sense of phenomena in the natural and design world, and it also emphasizes engineering to solve problems. And I really like this acronym. How do we select phenomena? What do we want students to be able to explain, right? The phenomena that we as teachers want to select has to be specific, is observable, it applies to science, and it's relevant. And I'll give you a specific example in the classroom too. Very quickly about NGSS, it has 13 disciplinary core ideas. So when we were growing up, this is basically what we focus on, right? The content. So NGSS goes from kindergarten all the way up to high school, which is what I love because it has this very clear progression of how they think science should go, right? Like, so for example, when we were growing up, we might be taught the water cycle in elementary school. Well, NGSS says, water cycle, you know what? Developmentally, students cannot really understand the science behind it until they're middle school. They really need to understand what's happening in the molecular level to be able to really explain it and apply it. And that happens in middle school. So for me as a science teacher, it's really liberating. I now know, okay, in middle school, this is what they should know, and this is what they will cover in high school. This is what I need to prepare them for. Same thing for the primary years teacher. The homeroom teachers teach them science, but I as a science advisor, I help them to develop the science lessons. So I give them I give them advice on like, I don't really think you should cover this in science class. Or, okay, you can cover this, but this is the expectation. Don't expect them to be able to think beyond that because that's setting the expectation too high. Or in this particular content or core idea, it might sound simple, but this is really what you want them to try to observe. So core ideas, very important in NGSS. Cross-cutting concepts, really, really important. Same thing like IB, NGSS has 7 cross-cutting concepts, and there's actually a lot that are connected to IB. So for example, function appears as an IB concept as well as an NGSS concept. And it turns out, I found out that one of the person that was involved in developing NGSS is an IB trainer and teacher. So I was like, oh, I found that out through a workshop in December. That's why they are so similar. The language they use are so similar. There's a reason for that. It turns out, it seems like IB was actually ahead of the game. They knew this was where instruction had to go. And thankfully, at least on the science part, they caught up, which is very nice to see. And then there are 8 science and engineering practices. And I'll be showing you a couple of different slides, but be aware that every time it's green, it points to a concept. And every time it's blue, it points to a practice. So, for example, I'm going to use a classroom example. This is a 3rd grade unit of inquiry across America. This is the transdisciplinary theme. So when Randy and Joy was talking about how they cover 6 different units, that means 6 different transdisciplinary themes in a year. And they circle back. So for example, where we are in place and time, they have that in kindergarten, that theme. In 1st grade, they have where we are in place and time. In 3rd grade, they have where we are in place and time. So those themes always circle back, but they see in the different contexts. So one year, they could focus more on historical figures. That's my daughter in 2nd grade, right? In 3rd grade, they focus more on geography, right? But it's the same inquiry into a particular theme. So in this theme, they learn about the history and geography of the United States to help understand culture and ourselves. So that's the unit of inquiry. And this was the key concept that the homeroom teachers picked up, form and perspective. And form, for example, in the IB, from the science lens, you would ask questions like, what is it like, right? For most things have a form or shape with an outward or visible manifestation or an internal structure. Can you already imagine what we could maybe inquire into in science class? I'll just give you guys a moment to think, and then I'll share with you what we decided to do in science class. So for every single unit of inquiry, we already pre-planned the science instruction. We looked at NGSS core ideas and we said, okay, and it's also broken up by bands. So K to 2nd grade is one band, 3 to 5 is another band under NGSS, and then middle school has its own core ideas to cover. So for example, in the K to 2nd grade band of core ideas, we said, okay, this particular life science core ideas, it really fits well with this particular unit in kindergarten. So you guys will cover that. And so 2 years ago, before the start of the school year, we looked through all the NGSS core ideas and we divvied up. Okay, you guys will cover this, you guys will cover that. And now we are developing or really solidifying what phenomena we will use with all these core ideas. Okay, so form. What did we end up choosing? First of all, this is how, if you ever want, I can give you a copy of this. It's maybe 9 pages long. This is an example of what a core idea looks like for NGSS, okay? So we decided to pick natural resource as the core idea in science, to inquire about in science. Because every state in the United States, in New Jersey, what kind of natural resources do we have? How do we generate electricity? What do we use? Do we use more natural gas versus or coal, that kind of thing? So that's where we started off. This is the core idea. Energy and fuels that human use are derived from natural sources, and their use affects the environment in multiple ways. Some resources are renewable over time, and others are not. So that's what they inquired into. And because we brought up the idea of energy, then we dived into it. So what is energy? How is energy transferred? So another core idea that we discussed about was energy can be moved from place to place by moving objects or through sound, light, or electric currents. And energy can also be transferred from place to place by electric currents, which can then be used locally to produce motion, sound, heat, or light. The currents may have been produced to begin with by transforming the energy of motion into electrical energy. So you can see from this chart what NGSS would like them to be able to understand after going through different kinds of phenomena that's related to these core ideas. So in terms of the lesson structure, NGSS requires students to do 3 things. They need to be able to gather information in a variety of ways, right? this is one thing that it blew my mind as a teacher, right? Every time we used to start science lesson, it's always about, okay, so what do you already know? NGSS says, I don't care what you know. I want you to ask questions. Because if the students come with, oh, I already know a lot, then they check out, right? So we ask them, when we present them a phenomena, what don't you know? I don't care about what you know. What don't you know? Okay, by the end of it, you should be able to answer your own question, right? And so when we come up with a phenomena, we also want to direct their questions, right? Because their questions can be all over the place. So I'll give you an example of what I mean, but know that your student, the first thing the teacher wants them to do is ask questions about a phenomenon. And then they will obtain information or conduct an investigation, basically gather information in a variety of ways. And this is usually where we stop in traditional school. We're done. We've gathered our information, we've conducted our investigation, you're done. And NGSS says, you're not done. You need to reason with it. If your child is not able to apply the information that they got, they're not able to reason with it, that information is not theirs yet. They haven't gotten it. How do you know whether they got it? They have to find a way to make their thinking visible, right? So that's where the reason is, to analyze data, develop model, or other ways, and then to communicate. And that third piece is something that I'm still working on a lot, on how to develop it with the students, is how to communicate in a way that people can understand you, and also to be able to receive feedback. For students to learn how to give constructive feedback, even in middle school, it's really hard because it's like, oh, okay, now give feedback to your friend about what she just read, her explanation. Oh, it's nice. No, I'm sorry. What is nice about it? Why is it nice? Like, can you give me more? And it's really not easy because we always, even as adults, default to it's good or it's good enough. What is good enough about that statement that she made? Give me explicit example. What's your evidence? You know. So 3 things: gather, reason, communicate. And again, this is all in blue because these are the science and engineering practices that it wants students to do in the classroom. They are called performance tasks. All right, so back to our 3rd grade example. The phenomena that I'm giving you is one about energy transfer. So the teacher, for me, when I start my middle school classroom, they come into the room, they see the phenomena written on the board, right? Sometimes we see a splash when a ball hits the surface of water. First step, ask questions. And for me, I direct them, we normally direct them to ask specific kinds of questions, right? Because otherwise you'll get things like, oh, what ball are we using? No. Okay. I want you to ask questions about the effect of the ball when it hits the surface of the water. And again, every question should have a practice, so the practice is asking questions, and a concept, effect. You can ask me all sorts of questions, you can, but one of your questions must be about effect. So it's hard for them, right, initially. I don't understand how to ask a question. I can give you a lot of information, but you're telling me don't give you information. I'm supposed to ask a question. So I start with sentence starters for them. Okay, so when we look at the word effect, how can we start a question? So for example, okay, keep going. Does what? Does the ball, okay, does the ball what? What kind of effect do you think you will observe? And ask a question about that, right? And it's really not trivial. When I went to the workshop last year, I got stuck too. I don't know how to start my question. But as you practice, and my middle schoolers are there now, because we've been practicing for a long time, from the beginning of school year, they're getting there about asking a question that's very relatable to the phenomenon, and sort of like getting them in the thinking direction that I want them to be in. So ask question, and then depending on the phenomena, a lot of times for physical science, it's easy to come up with investigation. So for this one, they needed to plan and conduct an investigation to see the effect of changing the mass of the balls and the height above the water at which the ball is dropped from on the water. So this is the kind of materials they were given. And as you can see, it's very different from traditional way when I was growing up. When I was growing up, we were given a textbook. The textbook will have the experiment. you follow the experiment, you're done. You write down some observations, conclusion, you're done. NGSS says this is not the world we live in anymore. You need to come up with your investigation. It can be simple, but it should not be a cookie cutter experiment anymore, especially for the lower grades where it's not complex stuff that they are using, and they do have prior experience, right? Everyone has thrown a rock. So it's not impossible for them to come up with a simple investigation like this, but very directed. I'm not asking you to investigate any, take a ball and do anything you want to it. I want you to change the mass of the balls. Okay, so what does mass mean? And it doesn't mean that I give them this and I don't guide them at all. We still guide them. Okay, so if the investigation is about changing the mass of the balls, okay, so I'm going to pretend these Easter eggs are the balls, right? They are empty. Okay, I want you to change the mass of this ball. What could you do? First of all, what is mass? Any ideas? Matter. Okay, I like the word matter. So how do we change the mass? If matter substitutes for mass, okay, how do we change the matter of this ball?
Add more. Add more.
I put something in it, right? And so I said, okay, these are your materials. What could you put in it? All right, so maybe I put one stainless steel ball in it. And here we have a scale, all right? How do I know I've changed the mass of this ball? All right, let's turn on the scale. We measure it before, we measure it after. Bam, you have some quantitative measure of mass. You've shown me, you've given me evidence that you've changed its mass, right? Because you have a number, right? And we can talk about units of measurement, lots of things you can cover in just one simple thing. All right, so good. We have these, we put something in. This was filled with water, you drop it in. Okay, what did you want to see the effect of? All right, so we changed the mass. We wanted to see how it affects the surface of the water, right? All right, so as you're doing the investigation, look out. Look out for what you want to see. So based on prior experience, right? If you drop a small pebble versus a heavier pebble, what did you notice? On the surface of the water. A bigger or smaller splash, right? And so before they run the investigation, they already should have like a hypothesis. They already should have a clear procedure that you're going to follow. And usually in every investigation, we want to ask them, okay, what do we want to keep constant? What's our independent variable? What's our dependent variable? All the same mechanics of a scientific investigation should be there, whether it's kindergarten all the way to middle school, right? It's all the same components, just how deep you want to go or how complex it is, right? And then changing the height, we have measuring tape here. They change from 50, I think, to 200 centimeters. And then again, they just observe whether it's a big splash or a little splash, right? Okay, so that's what they did in terms of the investigation. But if you go back to the core idea, they need to be able to explain, right, why they saw that observation, right? So this is an example of and so they gathered their investigation, and then they had to develop a model. So in the developing model part is always about explanation. So when I was growing up, a model can be a drawing, right? You draw a cell, you label the cell, bam, I have my model. NGSS says, no, that's not a model. That's a very pretty picture, because if your drawing doesn't explain anything, it's just a drawing. A model has to explain something. So I always tell my middle school students, absolutely, you can start with a drawing with a caption. That's not enough. Give me more. What does your model help you explain? And usually they're given what they need to explain about, right? So for example, in this model, it needs to explain the effect of changing the mass and changing the height above the water on the surface of the water, on the splash, right? So this is an example of student work. And I don't read Chinese, but what I understand is this person, as you can see, shows a much bigger splash when it's a heavier object versus a lighter object. And this is third grade. This I can accept, right? It actually shows a difference, right? They might not write complicated sentences. Like middle school, obviously, this won't be enough. But in third grade, yes. Okay, you can actually see a difference in the drawing, and I think this says observation, something like The bigger.
The heavier one made a bigger splash.
Perfect. Right? Drawing, explanation, model. All right? And then this is the conclusion, which for third grade is a good explanation. So,
The conclusion, it says the heavier object produced more energy.
and for third grade, that's fine. In middle school, I will whack them for produce. I would say, no, that's the wrong vocabulary. But for third grade, that's okay, right? This is the level that they can produce at that grade level. So again, gather information to develop a model and then to explain and to be able to share with each other. And that usually happens a lot in low grades in terms of like discussions as a group with peers and the teachers. They will talk about it. But this is a great example of the student work.
What's the difference between the model and the picture when it's not a 3D? What is it?
A model has to explain something. A model has to explain something. So if it's just a picture without any explanation in it, then it's not considered a model. So even if the student if the student should draw this and repeated it here, I wouldn't accept that as a model. Because what did it explain? Right? You have to show a change. What do you change and what did that result in? Okay. Okay, and this is communicate. And that's it.